Hello and welcome to Empowered Learning. This is the third video in the Logic Theory video series. And so I wanted to start off this one with alternative wording for conditional statements. And so we've already talked about the basic conditional statement, basic if this, then that statement. So here, if P happens, then Q happens. So and here we just have alternative ways of being able to say this same conditional statement. So one alternative form is to say Q happens if P happens. And so another way is to say P will happen only if Q happens then. And then here it says that P is sufficient for Q and Q is necessary to happen for P. And so just to throw this in here, when we talk about biconditional statements, if you remember that this is the same as saying if P then Q and if Q then P. And so when we say it that way, we say that a biconditional statement is both sufficient and necessary. Okay, so the statements are both sufficient for each other and as well as necessary. Okay. Now we see here for the Q if P, it says here the if is still associated with P even though it occurs later in the sentence. And for the second one here, P only if Q, recognize that only if does not say the same thing as if. And so the if condition is the hypothesis. The only if condition is the conclusion. Okay. So when we say if, it's just a hypothesis, but if we say only if, then that's actually part of a conclusion. And of course, for the other two, we mean here that the sufficient condition is the hypothesis. Okay. And here the necessary condition is the conclusion. And so when we say sufficient, we're saying that to get us in the ballpark, we need to have this. Whereas necessary, we're saying that everything breaks down unless we have this particular statement. All right, so now let's move on and talk about syllogisms. And so we see here that a syllogism consists of a set of statements called premises, followed by a statement called a conclusion. Okay. So it's a specific type of argument where you start off with a set of statements, you set some premises, and then you have a particular conclusion. A syllogism is considered to be valid if whenever its premises are all true, then the conclusion is true. Okay, so again, syllogism is basically a type of statement that is an argument, and whenever that syllogism is valid, we know that because we know if whenever its premises or the things that come before it are all true, then the corresponding conclusion is true. And if the conclusion can be false, even though all the premises are true, then we note that the syllogism is invalid. And so the way that we're going to show this is by using what we call Euler diagrams. So when we use Euler diagrams, they look a lot like Venn diagrams if you've watched my set theory videos, but we call these Euler diagrams because that's just what they are. And we're not listing things within a set, we're just kind of grouping things of a certain type together. And so it's a little different, and once you see it, you'll actually see the difference in between a basic Euler diagram and a Venn diagram. So let's look at our first example to kind of get an idea of what this is like. So we have our syllogism here, and of course this is our first premise, this is our second premise, and then this is our conclusion here. Now the way that we set this up is we're going to use our quantifiers to let us know what's going on with the situation. Okay, so we know that when we read our first premise, we know that all people are going to have to be inside the category mortal. So that's why here you see that inside mortal, we have this subgroup called people. Okay. And we say that Socrates is a person. So of course, Socrates has to be inside the set of people. So here we see Socrates right there. Now, how we know that we have a valid argument or not is that if our conclusion, which is therefore Socrates is mortal, if we can only put, in this case, Socrates in one place, then we know that then we know that the argument is valid. If we can place Socrates in other places, let's say more than one place, then we know that the argument is invalid because there's a situation where Socrates may not be what we're saying here, which is mortal. But since all people had to be mortal, and Socrates is a person, he has to fit inside people as well as the set mortal. So this is the only place he can go. We can't say that he's here, because if he's here, then we're saying that he's mortal but not a person. So, we're saying like he's a dog or a cat or something like that. But we didn't say that here, and that's not part of the argument. So since we know Socrates is a person, that's true. The only place for him is here, and thus we call this a valid argument. Okay, so this syllogism is a valid argument. All right, let's move on to the next example. So for our second example, we have our two premises here, and of course, probably didn't say this in the previous example, but I'm going to say it now. These premises, we're going to use these things are ANDed together. So let's say if I call this A and I call this B, then what we're kind of saying here is that A and B like this, and as a result we get let's say C, for lack of a better way of putting it. Okay, or probably a better way to say it, yeah, so that's probably the best way to say it, like that. So just make it simple. All right, so here we know that we're saying all poets are good spellers, so that's our premise here. So we know that the poet has to be inside a set that says good spellers. So this is everything that we are considering. And of course, we have this set here called good spellers, and we know that poets have to be inside of there. Okay. Now, we're saying that Dante is not a good speller. Okay. So since Dante is not a good speller, he has to be outside this set. So this is a place where he can be. Now we know he can't be a good speller, so he can't be in here, and we know he can't. He won't be able to be inside the poet thing either because he has to be a good speller. So here we have the conclusion, which is Dante is not a poet. And of course, we know that this is the only place Dante can be, so of course he can't be inside poets, so our argument here is valid. So thus, this syllogism is a valid argument. All right, so let's look at another example. So before we look at this other example, I want to make note of one thing here, and that is that I know that we're saying we have these premises here. These may not necessarily be true statements. Some of them may be false, but we want to remember that an argument can be valid even if the premises or the conclusion is false. Okay, that can actually be true then. So when we look here, of course, we see that Dante has to be here, but I mean, we don't know for certain that Dante is a good speller or not. We don't even know if he's a poet. But according to how our argument is structured, our argument would be valid based upon what we're saying. All right, so this will be an example of an invalid syllogism. Okay, and so we start off here with all tigers are meat eaters. So here we know that tigers has to be solely inside of the meat eater set. And we're saying that Simba is a meat eater. So here, where are some possibilities for Simba to be? Well, Simba could be here. He could be a tiger and a meat eater, or Simba could be here. Let's say other things that eat meat. We know people. There are some people who eat meat. And so they're meat eaters, but they're not necessarily tigers. So we see that Simba could be a tiger or Simba could not be a tiger, but still eat meat. So this conclusion here, which is Simba is a tiger, we know that this is going to be an invalid argument here because Simba can be in more than one place. Okay, and again, remember, if an argument is valid, then we know that when we do these Euler diagrams, the conclusion can only be in one space or one set. Okay. Now, before we do our next example, one of the things that we need to know about syllogisms is that the quantifier sum, and of course that's an existential quantifier, can be misleading in some of these syllogisms. And so all of the Euler diagrams you see below represent the premise of sum of something A are B. So some A's are B's. So you'll see here that some A's are B's, so that means some here, some are not. Here, some of A are B's. Okay, so of course in this case we have all of A's that are in B's, but there are some B's that aren't A's, and so that's the point of that one. And of course we have it the other way. We have all A's are B's, but not all B's. Well, all B's are A's, but not all A's are B's. So we have all these three cases here where we could place a person or a thing inside here or outside. We can place it inside or outside, inside or outside. When we have a valid syllogism, there's only one place that we can place it. Okay, and our next example kind of give us an example of what we're trying to illustrate here. So here we look at this syllogism and we first say that all cars are manufactured after 2007 have driver side airbags. Okay, so if we want to look at this, we know that we're looking at cars manufactured after 2007. So cars manufactured beyond 2007. And of course, here, all of them have to have driver side airbags. So here's this set within here called driver side airbags. Okay. We'll say that some cars with driver side airbags have passenger side airbags. Okay. So here, if we were to actually draw that, we could have something that looks like this. So this is the set with passenger side airbags. And we're saying that some cars with driver side airbags here, which is mainly these that are in here, will have passenger side airbags as well. Okay, and so the conclusion is some cars with passenger side airbags were manufactured in after 2007. Now the issue here, as we look at this, how we figure out this is a valid argument, we figure out where can all these cars be. So we say some cars have driver side with driver side airbags have passenger side airbags. Okay, so if we look here, cars that have driver side airbags, well, they could be here, they could be inside of here. Let's see if I can actually get drawing here. Well, let me erase that. So they can be in here, but they can also be in here. So passenger side airbags and driver side airbags, they can be with cars that are manufactured after 2007, and they can be cars that were not manufactured after 2007. And so the issue here is that we could place the cars that have driver side airbags and passenger side airbags in two places, mainly with cars manufactured after 2007, and of course outside of this will be cars manufactured before or in 2007. And so because of that, this particular argument is invalid. Of course, if we look at the slide here, this is a nicer version of this, but we see that the conclusion does not follow from the premise here, mainly because we have a situation where we have the cars that have driver side airbags and passenger side airbags could be in two different locations there. So this concludes the discussion on validating syllogisms, or to say, or do we have a syllogism that is a valid argument or not. And we're also at this point going to end the logic theory video series. So again, I hope this helps out a lot in your studies, and let me know if there's anything else I can do for you. Take care and good luck.